This morning, the SPC issued an enhanced risk for regions in Mississippi, Alabama, and parts of Louisiana here. This is in a 10% hatch tornado risk, which was a little bit of a surprise to see waking up this morning. But we're going to be looking at the synoptics of this event. We also have this 30% wind damage risk here. So we're going to be looking at the synoptics of this event, maybe some cams as well. And in addition to that, we're also going to be taking a quick look at the day 4 outlook. We have an enhanced risk for day 4 already as well, due to a strong upper level trough that we're moving through. And we're going to be looking at the synoptics of both of these just now. So come with me in this video. Hello everybody, welcome back to the channel. We're going to be looking at the severe weather today. So, I was already looking at it. So let's look at our 500 millibar map just to get a synoptic overview of our environment. And you can see immediately this massive trough, right? Pretty strong flow already, but very large amplitude trough here. Again, just very large. You can see this moving on throughout the day, even deepening a little bit. Pretty consistent right there where it's at, but we're slowly moving on to the east throughout the day here. And again, just for reference, this is our time we're looking at. So 12C is going to be 7 a.m. Eastern time or 6 a.m. Central time, just for your own benefit. And if you want to see what I'm looking at, if you forget, again, up here in the top left corner, and more information up there, and on the left side of the screen if you're able to see that. But here in this rat model, again, large 500 millibar trough, lots of forcing, basically being forced over our region there. I think 250 millibars for a jet stream, same thing, lots of pretty strong upper level jet. Let's see what our vorticity looks like. We're lacking a little bit in the vorticity front. But you can see at the moment we already have some vorticity out ahead of this trough here, and this might be helping to strengthen a little bit of a surface low. It won't be a very intense surface low, but it will be helping to strengthen that. Let's look at our 700 millibars here. You might even see semblances of a little bit of a shortwave right there. Let's zoom in here, the southeast sector, and you can see that little bit of enhanced flow right there. A little bit of kinks in the contour lines here as well. That could be indicative of that little shortwave helping to probably force a surface low, but also help with some forcing earlier on in the day. Relative humidity at 700 millibars as well. Lots of moisture up here for any storms that are trying to form. Let's see, 850 now. Again, it's a very similar story here. We have that increased lower level jet with a pretty strong southerly component as well, so that could aid in some tornado, looping some photographs, really helping to enlarge them with that strong lower level jet. Let's look at our temperature as well. Very warm air. Again, good moisture basically all throughout these profiles. That's one thing I'm going to mention as well. There's definitely this flooding risk for today. We look at our precipitable water. There's lots of precipitable water here. 1.5 inches in some regions here as well. So that is definitely a risk for today as well. You can see this even nearing 2 at some locations here. So lots of precipitable water is in play for today. Now let's look at the surface. You can see there right there again, surface low. Here's 12Z initialization for this wrap run. Again, very similar story. You can see the cold front really begin to form there. A little bit of it's hard to really show on here, but a little bit of a surface low forming. You can see our wind barbs a little bit of cyclonic spin right there. And then you can see that really start to ramp up there on 20Z. There's our little surface low. We got that trailing cold front, good open warm sector. A little bit of veered flow if you're in Louisiana or Mississippi. However, you do have a good amount of southerly flow in other regions. A little bit of a warm front here as well. So pretty small open warm sector, but a pretty intense one. Dew points are definitely where you need them to be. In initialization, actually, you don't have very good moisture, but due to this fairly strong surface winds on the ocean here, look at these 15 knots over the ocean here. That's going to really help advect. You can see on land as well, very strong warm, moist air advection from the Gulf. 15 knots, 14 knots. Again, pretty strong flow at the surface. That should really help you get that moisture, and it should not be an issue at all. And again, look at those dew points hitting 70 at some locations here. And yeah, so let's look at instability as well. Here's our surface-based cape. Again, you can see in the beginning, not very much, but as that advection begins, you're going to get instability very quickly near that Texas and Louisiana border. Surface-based cape really just kind of blows up, especially down here in southern Louisiana. So again, all that bubbly cumulus we talked about, actually I hadn't talked about that yet, but there's lots of bubbly cumulus looking, if we look forward in just a second, you'll be able to see that. And you can see how this cape is already forming there at 20Z. around somewhere in the range of 1,500 to 2,000 joules per kilogram, but you can see all this blue area is above 1,000, so it's pretty good instability, especially considering in a completely uncapped environment for quite a while there. Even into the overnight hours there, you can see 6Z, that's midnight local time here in Alabama, but you can really see that that cape really, the instability really lasts throughout the night there. Let's see if the 9Z wrap, the 9Z wrap can be further. You can see it even lasting into tomorrow. So you'll have that instability for quite a while there. And that really helps to continue to feel those storms. 3 Cape in particular in the lower levels where instability is, you can see a lot of that dies down there after sunset. So 6Z is probably sunset there. You can see it really dies out pretty quickly. But throughout the day, we're going to have a lot of lower level instability. And, you know, if we have any good photographs as well, that could really help to stretch that any surface circulation in the vertical for tornado genesis. Mass convergence, lots of convergence everywhere. And in particular, I also want to look at ahead of this boundary here, the cold front. You can see a lot of convergence somewhere here in Louisiana, right? I mean, you see the colors kind of blow up there a little bit of a convergence band. And so, if you look at the surface as well, we might see this a little bit. You can see the vectors here, the wind barbs do get a little bit, you know, messed up here, and this might be because the wrap is also a cam, but there is this semblance of convergence and storm development here in Louisiana as well. Let's look at our cams now, because we look at our synoptics. Here's our NAM nest. Let's look at our simulated reflectivity. You see, actually, this is a very fresh run as well. But you can see in particular here, lots of these little, you know, little lines here, right? That's a lot of bubbly cumulus, possible convergence here, right? So you'll see that bubbly cumulus here in the open warm sector, a few storms forming up here or over there, and then over here again, pretty strong convergence band being shown right there. That could really be a factor. Let's take a sounding. I'm not sure if this will work. Yeah, that didn't work earlier. Let's just check the wrap sounding at the same location, same time. You see the kind of environment these storms might be going into, and then we'll look at our environment from the MCS that will be forming as well. You can see here again, we have that southerly flow a little bit veered, which might not help the tornado risk a bunch. However, you do have that pretty good SRH values there. And surface to 1 is about 250 meters squared per second squared. That's a pretty good value. Same thing for surface 3 kilometers, about 300. Again, very good values of SRH here for supercell development and tornado development as well. The only thing really lacking is going to be our lapse rates. Because of the forcing, I mean, you can see in our photograph, or, well, if you look in the CUT here, above 700, you have at least 50 knots of flow, basically everywhere. You get 100 knots, 200, 90, 80, 500 millibars, if it's about 65. So we have very strong forcing throughout basically the entire profile here. And that's going to really aid in storm development. So what we are lacking is going to be that thermodynamic lift, but we do have a lot of upper level winds, basically helping to force these storms upwards. But again, lacking a little bit in the shear category. We have strong directional shear, not as much, strong speed shear, not as much directional shear. But we do have that southerly component, and if winds are a little more out of the east, that could change things quite a bit. And again, check how moist this profile is. You can see lots of moisture, a little bit of drier air at 700, but otherwise pretty moist throughout the profile there. So that's definitely something to keep in mind looking at this profile. Also, I did want to mention, if you guys have seen off the, where we talked about Texas and Louisiana, with that cold front, you do have this kind of sprawling QLCS, and that could also be forming any circulations. Let's look at HRRR, how this shows it. HRRR has a little bit more supercell development out ahead of the line there. You can see a few little storms, possibly, well, likely severe as well. Let's check 6 updraft helicity swaths. You can see we're going to have rotating storms. HRRR has a few little rotating storms here out ahead of that boundary again. And once these storms get going again, they're going to be ingesting a lot of more moist air, and it could be somewhat long track as well. We saw this sounding here. We have that right mover vector in a very good spot. So if you're really able to get a good right mover supercell, that could lead to, again, fairly long track cells as well. As we talked about that, oops, well, that's active tops, but you can see, yeah, these would actually, I didn't mean to click on this, but you can see how high up some of these storms could go. Or this is, never mind, this is storm relative felicity. I didn't trust this as much, but storm relative felicity we talked about. Actually, didn't mean to click on that. I do apologize. There we go. Reflectivity again. We have that line behind. Let's take one. I love sounding, so let's take one more. Ooh, what's the point? Let's see. We'll take one. Trying to get one where you're on the line. Probably here is a good bet. Let's take one right there, and you'll see again. Very similar story to this, most likely. I'm curious how the environment might change, being right ahead of that cold front. A little more forcing it looks like, especially stronger 850 as well. Yeah, less thermodynamics as we talked about. The only real lacking thing is this thermodynamic lift. We do have a lot of upper level flow, really strong flow throughout the entire skew T, and that's really going to help to mitigate that issue with the not very good lapse rates. So again, that's their storms. They'll move on and basically congeal probably about midnight and move on to the east, where they will pose a threat tomorrow. I believe the SPC has they have this little 2% out right now, but that might go up depending on the severity of these storms. So with that, I think our discussion for today's event is a wrap. Let's look at our next event on the for the day 4 outlook here. So, and we talked about this. Let's hover over this. We have a 30% enhanced risk over regions of Mississippi, Louisiana, parts of Alabama, parts of Arkansas here as well. But also a very large slight risk around that as well. So, a pretty big event, especially considering that we have a day 4 enhanced risk. Doesn't happen too often. So let's look at our synoptic environment here. Let's get our ensemble GFS out as well, just so you can see how well the models are agreeing on this. You can see there's that big old trough we're talking about. Very large amplitude as we talked, like very large amplitude as we saw in our case as well. A little bit lower pressure in there. Yeah, a little bit lower pressure. We can see even a little bit of a shortwave on the eastern side of this, helping to force even stronger flow. I just want to make sure I'm on the right day here as well with a quick check. Yeah, so it looks like our day of interest is going to be Saturday. So this is for Saturday. It says here as well, Saturday to Sunday. Sunday overnight, really, but this is a Saturday event. So we're looking at that. And let's look at our 500 millibars. We're going to really just be using the GFS here. Oh, actually, I can get a picture on the NAM. So the NAM will get me out to basically right where I was. A very similar story, very large amplitude trough. A little bit of a ridge out here, but this should lead to some divergence. Let's see, wind speeds, very strong jet stream as well. GFS should have the same thing. Notably, the GFS does have a little bit more of a deep digging trough, less large amplitude style, a little deeper digging. So we'll see how that goes when the day comes, or as we get closer to it. Hopefully I'll have an update out if I can find the time to. 700 millibars, again, very similar story, a little bit more positively tilted in this case. We do have a lot of upper level or mid level forcing, 850 at the lower level here, and similar story as today's event. Honestly, very similar events here. We have that stronger stream of flow there, probably warmer air, yeah, lots of warmer air there as well, and lots of moisture there as well. Very helpful for that any storm development. Now let's look at the surface, and one thing you'll note here. Actually, did forget to look at this. Let me check that real quick. Looking at our vorticity here, very different. So our current trough, we look at the GFS here, not much vorticity with it. It's a little bit positively tilted, not perfectly how you'd expect for a typical 500 millibar trough, especially for our day of interest. We have a little bit of vorticity, dorm. We have a little bit of vorticity out ahead of this, but you can see as we move further for our next trough on Saturday, much stronger vorticity, and the vorticity is forward. So this is going to really help in surface low development. Let's look at our surface map here, and you can see that's a very clear difference between these two events. Much stronger surface low and stronger surface flow as well. So lead to a lot more moisture and a lot larger of an area here. You can see, look at that larger slight risk as opposed to this slight risk we have here. And you can see that enhanced risk much larger in size than the current one. So let's look at our surface map now and just see what really happens. Here's 12Z. You can see we have, well, we go back even further. You can see we get surface cyclogenesis off the Rockies there around Friday. You can see pretty intense already. Just not really enough moisture, I would believe, for any thunderstorm development. Maybe some out here, but either way, not very good thunderstorm environment for that region. But you can see the surface low really strengthens. We have 1006 here. Yeah, pretty strong surface low until the actual event starts happening. But you can see at this point, I believe that's a 1006 it looks like right there. Like pretty intense surface low and surface cyclogenesis very quickly there. And then you can see 18Z Saturday, right when storms are probably going to be forming. Moisture is very strong. We have drier air out behind the cold front, but ahead of it you have a lot of warm, moist air. It's open warm sector right here. See it very nice with these temperature color filled temperature contours right here. See it very nicely. Then I move on to the a little bit more to the east here. You can see and just a large open warm sector here, which will likely last for quite a while. And you can see very strong southerly flow, a little bit of easterly sometimes ahead of it as well. But southerly flow is very strong. 850 lower level jet also very strong. Pretty widespread 40s all over the region, peaking at 60 in some locations. Again, very strong upper level. Basically, for both events, the forcing is very strong. It's very possible this event will have a better thermodynamic profile as well. Yep, here's our lower level lapse rate. You can see over regions Louisiana and Mississippi, we have a much stronger lower level lapse rate. Let's go here. Let's see what's going on here. And we'll take a sounding out here just to see what the lower level lapse rate is really doing. Both of these are in the open warm sector. Here is our closer to the cold front. You can see again that lapse rate at the surface much better than what we're seeing in our event today. Much better thermodynamics, but also coupled with this stronger upper level flow. You see warm air advection here in the lower levels, good instability in the lower levels. Yeah, good cape as well. And the one thing I didn't want to mention, this is on the GFS. This is 4 days out, and we already have at least 1,500 joules per kilogram of cape being shown here. Very similar story for the other location as well. A little more southerly in that case. You can see our photograph, more of a southerly component in there. But again, very high tropopause as well. But very large storms. Good again, good thermodynamics, and that's the main thing I want to mention. Thermodynamics for this system look a lot better than the ones today. SRH is a little bit lacking in this photograph, but again, I'm not going to go too crazy. I mean, it's not even lacking. I wouldn't call that lacking. It's 180 meters per squared per second squared. That's a very good SRH. Very similar story to today. Surface 3 is about 260, 250 for the other photograph. Both cases, very good for severe weather, especially this far out. So I'm a little worried to see how this will turn up as we get closer to the event. But definitely something to be looking out for. Might have some stronger downdrafts as well. You can see a little bit of this drier air entrainment could be helping in supercell development as well. I don't believe we have anything don't have any cams or anything that'll get out this far. But again, they talked about these various situations. We could have convergence anywhere ahead of this ahead of the cold front back there. I'm gonna call this. I think this is the cold front. We'll call it the cold front. It's very weird how there's warm air behind it, but it's very dry, so it is indicative of a cold front. But you can see again, very large open warm sector is the main thing to take out of this. So there's a large area for storm development. We can have wind risk upon that cold front, and plenty of supercells if we have any convergence bands ahead of that cold front. Looks like a very good system so far for severe weather, and not really what you want to see too much. But again, the cards are starting to line up. There's plenty of time for things to go wrong or for things to go right. So with that, I'm going to let time take its toll. I'll give this some time, and we'll have an update next time this is really any importance. But with that, I want to thank you all for watching. If you have any feedback on my videos, anything I can improve on, or anything you'd like to see, let me know in the comments below. Otherwise, thank you for watching. I appreciate you all, and I'll see you all next time.